Okay, so the next section that we're going to look at are derivatives of inverse trig functions. So this is derivatives of inverse trig. So the inverse trig functions are going to be sine inverse, cosine inverse, tangent inverse, secant inverse, cosecant inverse, and cotangent inverse. So we're going to derive the derivative of sine inverse, and then I'll give you the rules for the other 5, and you'll see how to derive the other 5 once we do this one. So the first one that we're going to look for is, what is the derivative of sine inverse of x? Now a little bit about notation here. When we say sine to the -1, that means the inverse. This doesn't mean to the -1 power. Sometimes you'll see it written as arc sine, but these are the same thing. These are talking about the inverse of sine. This is not 1 over sine. This is an entirely different function. This is the inverse of sine. Okay, so this is what we're trying to look for, is the derivative of the inverse of sine, or arc sine. So let's write down what we know. We know that sine of sine inverse of x is just x. We know that's true because these two are inverses of each other. So if you go back to when we were doing inverse functions, if you did the inverse of a function, you were just back at x. That means that the derivative of sine inverse of x is the derivative of x. So from knowing that when I do the inverse I get back at x, I can take the derivative of both sides. Now what is the derivative of sine inverse of x? Well, this is a chain. The outside function is sine, so the derivative of sine is cosine. Remember, I keep the inside part the same. Then I move inwards and I multiply this by the derivative of sine inverse of x. So I use the chain rule on the left hand side. Now what's the derivative of x? That's just 1. Remember, this is what we're trying to solve for. So I'm going to divide both sides by cosine of sine inverse of x. So the derivative of sine inverse of x is 1 over cosine of sine inverse of x. This is a pretty terrible formula for the derivative of the inverse, so we're going to see if we can simplify this just a little bit. So what I'm going to do, we'll leave some space here because I'm going to write a lot of things that are equal. I'm going to let y be sine inverse of x, which is the same thing as saying that sine of y is equal to x. Well, if sine of y is equal to x and I draw my triangle, that means for this angle y, I have opposite over hypotenuse. So here's my angle y. Sine of that angle is opposite over hypotenuse, which is x over 1, because x is the same thing as x over 1. What does that make this side? Remember, this is a right triangle. Using the Pythagorean theorem, that makes this 1 minus the square root of 1 minus x squared. So now what I've done is I've just rewritten this as 1 over cosine y, because I said that y was the inverse of x. What is cosine of y in the triangle that we just drew? Well, that's adjacent over hypotenuse. So square root of 1 minus x squared over 1, which is just the square root of 1 minus x squared. Which means this is 1 over square root of 1 minus x squared. Now this is the equation that we're going to use. So I'll write this on the next page. But what we did was use what we know about the inverse. We know that sine of sine inverse is x, took the derivative, used the chain rule on the left hand side, and then solved for my derivative. Then I found a better formula for cosine of sine inverse using a triangle, and I got that the derivative of inverse sine is 1 over square root of 1 minus x squared. So that's going to be our first rule. The derivative of inverse sine is 1 over square root 1 minus x squared. So that's our first rule. let's go through the other ones. Now these you could derive exactly the same way that we just did. If you do that, we get that the derivative of inverse cosine is negative 1 over the square root of 1 minus x squared. You'll get that the derivative of inverse tangent, or arctan, is 1 over x squared plus 1. So the reason we don't have a square root in the inverse tangent is because, remember, tangent is opposite over adjacent. So this isn't involving the hypotenuse at all. Now these three are definitely the most important, and those are the three that I would require you to know. But we do have the inverse derivatives of the other three. So I have the inverse of secant. Derivative of that is going to be 1 divided by the absolute value of x times the square root of x squared minus 1. I have the derivative of the inverse of cosecant is negative 1 over absolute value of x times the square root of x squared minus 1. So the relationship between secant and cosecant is the same as the relationship between sine and cosine. So one is just the negative of the other. And then lastly, the derivative of the inverse cotangent is negative 1 over x squared plus 1. Now again, the ones that I'm going to require you to remember are these, but you should know how to look the last three up and how to use them. So those are the 6 derivatives of inverse trig functions. So let's see, how do you actually use these? Let's let f of x be x sine inverse of x. And let's find f prime of x. Okay, so I have f of x is x times sine inverse of x. I'm going to have to use the product rule to find f prime. So u will be x, v will be sine inverse of x. Now what is the derivative of x? That's just 1. And what is the derivative of sine inverse? Well, we just learned that one. It's 1 over the square root of 1 minus x squared. So now using my product rule, I'll have that the derivative is u prime v, so 1 times sine inverse, plus uv prime. I'm going to write the x on the top. So 1 over, or x over square root of 1 minus x squared. So that's just coming from my product rule. So that's all that is. Let's do another one. Let's find the equation of the line tangent to f of x is going to be inverse cosine of 2x at x equals 0. Okay, so I'm finding the equation of the tangent line. That means that my answer is going to be y equals mx plus b. First thing I'm going to do is find m. Remember, m is always going to be f prime of whatever value I'm looking at, so I'm looking at 0 here. So I need to find the derivative. So this is cosine inverse of 2x. So this is a chain. So I'm going to write down the most inside. So what would I do first if I was plugging in a number? That would be 2x. Then I would do the inverse cosine. So what's my derivative going to be? We'll start at the bottom. What's the derivative of cosine inverse? That was negative 1 over the square root of 1 minus x squared. But I'm not going to write an x there. Remember, I write whatever the previous line above it says. Taking care of that line. Now I multiply it by the derivative of 2x, which is 2. So there's my derivative of f. Now I plug in 0 to find m. So I'll get negative 1 over the square root. Let's see, 1 minus 0 is just 1. So I'm going to get negative 2. That tells me that m is negative 2. So the steps are the same. I found the derivative, plugged in my x value, and that gave me m was negative 2. Now I got to find b. Remember, to find b, I'm going to use the point 0, f of 0. Always go back to your original function. Well, if I plug in 0 here, I'm going to get cosine inverse of 0. So what is cosine inverse of 0? That is pi over 2. You could look to your unit circle if you want to. This is saying when is cosine equal to 0? That would be at pi over 2. So far, I have that y is negative 2x plus b. Now let's plug in my point. I'll get 0 is negative 2 times, sorry, I got that backwards. Pi over 2 is negative 2 times 0 plus b. 0 times negative 2 is just 0, so pi over 2 is b. Which means the equation of my line is negative 2x plus pi over 2. So there is the equation of my tangent line. The steps that we took were not anything different. I still found f prime and plugged in my value. I still used my original function to find b. The only difference is that now we had to use the derivative of cosine inverse. Let's do one more here. Let's let f of x equal x squared minus 3x plus 1 cubed divided by tan inverse of 2x. And let's find f prime of x. Okay, so our function is x squared minus 3x plus 1 cubed divided by tan inverse of 2x. So this is a quotient. So I'm going to let u be the numerator. I'm going to let v be the denominator. I just need to find u prime and I need to find v prime. Then I'll just plug it into my quotient rule. So let's start with u prime. X squared minus 3x plus 1 to the third. This is a function within a function. So to find u prime, and I'll write the steps down here, this is how I'm finding u prime. The most inside function is x squared minus 3x plus 1. If I plug it in a number, that's what I would do first. Then I would take that number and cube it. So what's the derivative going to be? We'll start with the derivative of x cubed. That's 3x squared, but I don't write x. I write the previous line above it. Then I multiply this by the derivative of x squared minus 3x plus 1. So that's 2x minus 3. Okay, now I gotta find v prime. This is tan inverse of 2x, so this is again a chain. The most inside function is 2x. Next function is tan inverse of x. So now let's see, what's the derivative of tan inverse? That's one we just learned. That was 1 over x squared plus 1, but I don't write x. I write everything above it. And then I multiply this by the derivative of 2x, which is 2. Now I found my u, v, u prime, and v prime. I just plug it into my quotient rule. So f prime of x is going to be u prime v, so that's 3 times x squared minus 3x plus 1 squared times 2x minus 3 times tan inverse of 2x minus u v prime, so x squared minus 3x plus 1 cubed times 2 over 2x squared plus 1, then all divided by v squared, so tan inverse of 2x squared. So using the product rule, using the quotient rule, using the chain rule, none of that has changed, only now we have more functions that we can plug in. So use the chain rule the same way you've been using it, the product rule the same way, the quotient rule the same way. The only difference is we have 3 new derivatives to work with. So those are the inverse trig function derivatives.